Hello, Upper Six. This is just a quick demonstration to show you the diffraction pattern that is produced when you shine light through a circular aperture. Now, this is important when we're looking at the resolution of telescopes, because telescopes have got a circular aperture. It's basically the size of the primary mirror or the objective lens. And when the light comes in through that aperture, it's going to diffract, which means it spreads out. This produces a blurring of the image of a point object, such as a star, that you would see, even when the star is perfectly focused. The diffraction pattern that's produced is called an Airy Disc. Now, to try and simulate, well, actually show you what the Airy Disc looks like, what I've done is I've taken a laser pen. I have covered the front of the laser pen in silver foil, and then with a pin I've made a pinprick in the middle of the silver foil. Now the pinprick represents the aperture of the telescope. Now obviously it's very, very small. In this case, the aperture, it's probably about 0.1, 0.2 millimeters across, and that's to show you a wide diffraction pattern on the wall. So what I'm going to do now is just show you what diffraction pattern that's producing on the wall over here. So you can see the spot that it's producing. Now I'm going to turn the light out so you can see it more clearly. So it's a little bit overexposed at the moment, but basically you can see the diffraction pattern. You don't get a spot on the wall. What you get is a large central area, a central disc or peak, and then you get a series of bright and dark fringes in circles around that central disc. That's caused by diffraction, exactly the same effect that you've seen before when you looked at diffraction gratings last year and double slits last year. The only difference here is it's a circular pattern. So you get a central disc which has a certain width, and then you get a series of dark and bright coloured fringes. Dark fringes where you have destructive interference, and bright fringes where you have constructive interference. Now, as I said, the important thing about this is what the image of a star would look like in a telescope, and the smaller the telescope is, the aperture of the telescope, the more spread out this Airy disk is, which means that the resolution is worse. So if you've got two stars that are very close together, like a double star, you wouldn't be able to separate them apart very easily if their Airy disks overlap. So some of the notes I'm going to give you for this next section of work to do, you're going to look at something called the Rally Criterion, which basically decides what the resolution of a telescope is based on its aperture and also the wavelength of light that you're looking at. Okay, that's it. Thank you very much.